Hi guys, let's take a look at section P.6, which is on rational expressions. So in this section, we're looking at simplifying rational expressions and adding and subtracting and multiplying, dividing rational expressions. So the first thing we want to take a look at is what to do when they ask us what numbers are excluded from the domain. And this idea of looking at numbers that are excluded from the domain, or what we might call restricted values, that's another term you'll hear us say. That is basically just looking at where would the denominator equal 0, because remember, you can never divide by 0. So in this first example, we've got 4 divided by x minus 2. I want you to think about what number would make that denominator a 0. A quick way to do that is to look at, if I were to set the denominator equal to 0 and try solving it, what would I end up with? So x minus 2 equals 0, x would have to equal 2. So the number that's restricted from our domain is 2. So I'm going to say x cannot equal to positive 2. Let's take a look at the next example. We have x squared minus 1. This needs to be factored. So remember in the last chapter or last section, we talked about factoring a difference of squares. Hopefully you recognize that's what this is. This turns into x divided by x plus 1 times x minus 1. So this time there are two numbers that would make the denominator a 0. If we looked at where do these each equal 0, we would get negative 1 for the first expression and positive 1 for the second expression. So this would have two restricted values. X cannot equal positive 1 and negative 1. In the last example, we're going to have to factor the denominator before we do anything else. So I'm going to rewrite this as 9x. It's 9x divided by x squared plus 3x minus 18. I'm going to write this as the product of two binomials. We have x times x. What multiplies to negative 18 and adds to 3? So those two numbers would be positive 9 and positive 6 and negative 3. So we have x plus 6 times x minus 3 is the factored version of x squared plus 3x minus 18. Now to figure out where the restricted values would be, I'm going to think about what would make each of these factors a 0. So in other words, x plus 6. What would x have to be in order for that to be a 0 when you simplify it? And hopefully you see that that would be negative 6. So one restricted value is negative 6, because negative 6 plus 6 is 0. What about the other expression, x minus 3? What would x have to be that would make that expression a 0? And that would be positive 3. So again, we have two restricted values. X cannot equal negative 6 or positive 3. Let's take a look at example 2. So in example 2, they want us to simplify the rational expression y squared minus 10y plus 25 all over 25 minus y squared. So the first thing you want to do with these before you get into them too far is factor anything that can be factored either in the numerator or the denominator. So those factoring skills we talked about in the last section are extremely important. You see them right away. We're going to start using them. So make sure you practice factoring. You feel good about it. So we've got y squared minus 10y plus 25. That's a trinomial, so that'll break down into two binomials. The first terms are going to be y, what multiplies to positive 25 and adds to negative 10. And that would be y minus 5 times y minus 5. The denominator, 25 minus y squared, that's a difference of two squares. So that's going to break down into two binomials with opposite signs. So we're going to have 5 plus y times 5 minus y. And then anything that you can reduce, you want to go ahead and reduce it. Now at first glance, it doesn't look like we have any common factors top to bottom. We have a 5 plus y, that doesn't cancel with anything. We have a 5 minus y, but in the numerator we have y minus 5. These are what are called opposites. If you have, let me give you a quick little example here. If you have like a minus b on top and positive b minus a on the bottom, so where all the signs are opposite. See how the a's are opposites and the b's are opposite. That will reduce to negative 1. The reason for that is because if we factor a negative 1 out of either of these expressions, like let's say the denominator, this would give me a minus b on top, and if I took a negative 1 out of the bottom, notice that would change the b to a negative and the a to a positive, because that would, if I take a negative 1 out, that would make the signs in the parentheses opposite. And you notice that that is the same thing. Let me rewrite it. A minus b over negative 1 times negative b plus a. I could write that as a minus b again, couldn't I? So then you could think of those a minus b's as canceling. You have a 1 on top, and that just leaves you with negative 1. All right, so the long and short of it is when you have opposite signs like that, where you have a binomial and the signs are opposite for each term, it simplifies to a negative 1. Why am I bringing that up in this problem? Whichever term you look at in the numerator, either y minus 5, it doesn't make a difference, but do you see that you've got an opposite with what's in the denominator, the 5 minus y? So say the one directly above it. We have y minus 5 and 5 minus y. Those are opposites like we were just talking about. So those are going to divide out and just leave me with a negative 1. This is negative 1 that's being multiplied by the y plus 5. So I'm going to rewrite this so the negative 1 is in the front of the y minus 5 in the numerator and the 5 plus y in the denominator. And that is completely simplified. Let's try example 3. Before we do anything else, we need to make sure we factor anything that can be factored. So I'm going to rewrite the entire problem with things factored. So we have x minus 7 over x minus 1, can't do anything with that there, times, now I have x squared minus 1 over 3x minus 21. X squared minus 1, I hope you see that's a difference of two squares. So that's going to break down into x minus 1 times x plus 1. The order you write those in doesn't matter. You could write x plus 1 first. How about the denominator? We have 3x minus 21. That will break down. I can take out a 3 as the greatest common factor. So I have 3 parentheses x minus 7. Now, to reduce this, when you multiply terms like this, anything, excuse me, anything top to bottom that they share, you can simplify. So you see that you have an x minus 7 in the numerator here and an x minus 7 in the denominator here. Those will divide out and leave you with a 1 there, and a 1 there, times the 3. X minus 1 in the denominator here times the x minus 1 in the numerator here. Those will divide out, so that leaves you with a 1 and a 1 there. So then what do we have left? Remember, we multiply fractions, we multiply numerators over denominators. So we have 1 times x plus 1 in our numerator. And then we have 1 times 3 times 1, which is just 3 in our denominator. And that is multiplied and simplified. Let's take a look at letter B. So when we divide fractions, you may remember from high school that when you talked about dividing fractions, the second fraction, you have to flip it and change it to multiplication. Before we get into that, let's factor anything that can be factored. So we have x squared minus 2x minus 8 divided by x squared minus 9, or I should say over x squared minus 9, and then divided by x plus 4 over x plus 3. So let's start with the x squared minus 2x minus 8. I'm going to break that down into two binomials. So what multiplies to negative 8 but adds to negative 2, and that would be a negative 4 and a positive 2. The denominator, we have x squared minus 9, which breaks down into x plus 3 times x minus 3. Now, we were dividing all of that by the fraction x minus 4 over x plus 3. So I'm going to change it to multiplication, and I'm going to flip the second fraction. I'm going to use the reciprocal, so I'm going to write that as x plus 3 over x minus 4. So now is there anything that can cancel out top to bottom? So the x minus 4 in the numerator with the x minus 4 in the denominator, those will cross out and leave you with a 1. The x plus 3 in the denominator and the x plus 3 in the numerator here, those will also cross out and leave you with a 1. So now what do we have? We have 1 times x plus 2 times 1. So my numerator is x plus 2. The denominator, we have 1 times x minus 3 times 1 again. So my denominator will just be x minus 3. Okay, let's take a look at example 4. They're asking us to multiply or divide as indicated. So we have this big crazy expression. We're multiplying and dividing three fractions. So let me read it to you. It's x squared minus 9 all over x squared plus 7x minus 18 times x squared minus x minus 2 all over x squared plus 7x plus 12 divided by x squared minus 3x all over x squared plus 13x plus 36. So let's start by factoring whatever it is that we can factor. So in the numerator, hopefully you see that's a difference of squares. X squared minus 9, that breaks down into x plus 3 times x minus 3. The denominator, x squared plus 7x minus 18, that will break down into two binomials. So we have an x and x. What multiplies to negative 18 but adds to 7? And that would be a positive 9 and a negative 2. Times the next expression, x squared minus x minus 2, that'll factor into two binomials again. So that'll give us x minus 2 and x plus 1. The denominator, x squared plus 7x plus 12, that'll also factor into two binomials, x plus 4, I believe, and x plus 3. Now, for the last term, we're dividing the fraction. So I'm going to go ahead and change it to multiplication. Make sure you see what I'm doing here. I'm going to change this to multiplication, but I'm going to go ahead and factor it at the same time. So the x squared plus 13x plus 36 is going to factor and end up in my numerator of my last fraction. So that's going to break down into what? We need numbers that multiply to 9 and add to, multiply to 36 and add to 13. I think it'll be 9 and 4. And then the denominator, we have x squared minus 3x. We can factor out a GCF. It's not a difference of squares because of the 3 and the x, so it's going to just take out an x. And that leaves me with x minus 3. All right, so take a look. Anything in the numerator and the denominator that match, you can divide out. So we've got, let's see, we've got x plus 3, and I see that we have an x plus 3 down on the bottom of the second fraction, so we're going to cross those out. What else? We have an x minus 3 in the numerator here and an x minus 3 in the denominator of the last fraction, so those are going to cross out. We have an x minus 2 in the denominator of the first fraction and an x minus 2 in the numerator of the second fraction. Anything else? We have the x plus 9 in the first fraction in the denominator of the first fraction and an x plus 9 in the numerator of the last fraction. And then we also have an x plus 4 in the numerator of the last fraction and an x plus 4 in the denominator of the second fraction. One thing I don't think we saw in any of these examples, anything top to bottom can divide out, even if they're in the same fraction. I think all the ones we've seen, they've been in opposite fractions across from each other, but they don't have to be. They can be in the same fraction. But any common factors you have in any of the fractions, if one's in the top, one's in the bottom, they can divide out. So you notice I've got, a 1 here, a 1 here. I've got an x plus 1, a 1 here, a 1 here, and an x, and just an x in the last x times 1. So if you multiply all your numerators together, the only thing left in the numerator is the x plus 1. All your denominators, the only thing left is an x. And so after all that, that's our final answer for that expression. All right, let's take a look at the last couple of examples here. So now we're looking at adding and subtracting rational expressions. So the big thing you have to remember with adding and subtracting fractions is that they must have a common denominator. That's important. Multiplying and dividing fractions, not the case. But when you add and subtract fractions, you must have a common denominator. So let's go ahead and take a look at that. So must have a common denominator. We usually call it an LCD. A least common denominator, so they must have an LCD. If you look at this first fraction, we're adding 2x over x plus 4 plus 3 over x plus 4. So what do you notice right off the bat? They have a common denominator. So I don't have to do anything special. I can just add them together. We're going to add the numerators together, just like if I had a regular fraction. If I had 3/5 plus 8/5, for example, I would add the numerators and I would have 11. The common denominator would be 5, so I have 11/5. It's the same idea. So I have 2x plus 3 is going to go in my numerator. If they were like terms, I would combine them, but they're not. So I'm just going to write 2x plus 3 over my LCD, my common denominator, of x plus 4. And that's all we have to do for that one because they already had a common denominator. Number 7's got a little bit more going on because they don't have a common denominator. So they're asking us to subtract 5x over x squared minus 4 minus 8x over x plus 2. Before trying to get a common denominator, make sure you have anything that can be factored, go ahead and factor it. So I'm going to rewrite this as 5x over x squared minus 4. That factors into x plus 2 times x minus 2. Minus 8x over x plus 2. I can't do anything else with that. So take a look at your denominators now. We have x plus 2, x minus 2, and just x plus 2. So my LCD needs to be the combination of these denominators. Well, they need to have, basically every factor has to be represented in your LCD. So I need to have x plus 2. So let me write this over here. So my LCD, I need to have the x plus 2. What else needs to be represented though? I also need to have the x minus 2. And then the other fraction, the denominator, is x plus 2, but I've already got that represented because I needed it for the first fraction. So this is what I want both of my denominators to turn into. The first fraction already has this, so I don't have to change anything there. The second fraction, however, I need to multiply something by the top and bottom. If I multiply the same thing on the top and bottom, it's like multiplying it by 1. So what is the missing expression to make the denominator x plus 2, x minus 2? Hopefully you see x minus 2 is what's missing. So I'm going to multiply this by x minus 2 on the top and bottom. So let me rewrite what I have. So I have 5x over x plus 2, x minus 2, minus 8x times x minus 2 over the common denominator there, x plus 2, x minus 2. So now let's go ahead and combine the fractions. So we have 5x minus 8x times x minus 2, all in my numerator, over my common denominator, x plus 2, x minus 2. Now you want to go ahead, if you have any like terms in the numerator, you want to combine them. The only way to see if that's the case is if we distribute this 8x and see if we have any like terms. So that gives me 5x minus 8x squared plus 16x all over my common denominator, x plus 2, x minus 2. And you notice that we have a 5x and a positive 16x. Those are like terms, so let's go ahead and put those together. That gives me 21x minus 8x squared all over x plus 2, x minus 2. Every so often you'll come across one of these where something at the end will cancel if you completely factor everything. So it's a good idea to get in the habit of taking, after you've combined like terms, taking what you have at the end and factoring. So that numerator, if we factor out, we have a GCF of x. That leaves me with 21x minus 8. I'm sorry, 8x. 21 minus 8x all over x plus 2, x minus 2. Certainly you can leave things factored. That's not a problem. I'd recommend leaving the denominator factored anyway. If you forgot this step and didn't go to the last step, that's okay. That's not a problem as long as there weren't anything else that would reduce. Notice in this case, we can't reduce anything. This x is just an x. It can't reduce with x plus 2 and x minus 2. So this is as far as we can go with this fraction. Either of these answers would have been acceptable.